Welcome to Chapter 7 Incidents and Intrusion Response. This is your Professor Atif Fareed Muhammad. The disaster recovery steps taken after an information technology related disaster to restore operations. Forensic techniques may be best method for determining what caused the disaster and for avoiding to repeat it. Forensic process begins once an incident has been discovered, is not fully underway until after the disaster or an incident is contained. Incident response is the reactive component that follows contingency planning. It involves the actions taken during and immediately after the disruption to limit damage and reduce recovery time. An incident response plan outlines the steps to detect, respond to, and recover from incident such as data breach, natural disaster, or supply chain disruption. This plan includes roles and responsibilities, communication strategies, and procedure for assessing and containing the incident. Regular testing and updating of the incident response plan are crucial to ensure its effectiveness. Incident response plan in place to respond to fire, flood, hurricane, tornado, hard drive failures, network outage, malware infection, data theft, or deletion intrusion are common things. So let's take an example. Let's take a supply and logistics company as our use case. Contingency planning might involve identifying potential disruptions like severe weather, supplier failures, or transportation strikes. The company could develop contingency plans such as securing backup suppliers, establishing alternative transportation routes, or stockpiling critical inventory. For instance, if a primary supplier is located in a region prone to natural disasters, the company might source a backup supplier in a different region. Incident response in this scenario would involve activating a backup supplier relationship, rerouting orders and communication, and changes to relevant stakeholders. The company would also assess the incident's impact on its supply chain and take steps to prevent or mitigate similar incidents in the future. Regular drills and simulations could be conducted to ensure that the incident response plan is up to date and the staff are well prepared to execute it. Business continuity, incident response, and disaster recovery, all of these go into digital forensics, and let's look into that with an example. Digital forensics play a crucial role in the incident response process, particularly when dealing with cybersecurity incidents or digital crimes. In the context of the supply and logistics company, digital forensics would involve the identification, preservation, analysis, and presentation of digital evidence in the legally acceptable manner. This process helps the company understand the nature and extent of the incident, identify the perpetrators, and gather evidence for potential legal action. During an incident, such as a data breach or a cybersecurity attack on the company supply chain management system, digital forensics specialists would follow a structured approach to investigate the incident. The first step is preservation, where the affected systems are isolated to prevent further damage and the data is preserved to maintain its integrity, as we have been discussing in our previous discussions. This is followed by collection, where the digital evidence is systematically gathered from various sources like computers, servers, and network logs. The analysis phase involves examining the collected data to reconstruct the events leading up to the incident, determine the methods used by attackers, and identify the compromised data or systems. Business continuity plan is number one. Disaster recovery plan is number two. The business continuity plan focuses on keeping the organization functioning as well as possible until a full recovery can be made, whereas disaster recovery plan is a DRP is focuses on executing a full recovery to normal operations. So in the aftermath of an incident, digital forensics helps the supply and logistics company, which we are looking into at this moment in depth, in several ways. The findings from the forensic analysis can guide the company's remediation efforts, helping to restore affected systems and prevent similar incidents in the future. Additionally, the evidence gathered can support legal proceedings against the perpetrators if necessary. Furthermore, digital forensics can aid in meeting regulatory requirements, as many industries have mandates for reporting and investigating data breaches. Regular training and collaboration with law enforcement agencies can enhance companies' digital forensics capabilities, ensuring a more robust response to cybersecurity incidents. For example, if the company's online ordering system is compromised, digital forensics would help trace the origin of the attack, identifying the vulnerabilities exploited, and determine if customer data was accessed or exfiltrated. This information would be vital for containing the breach, notifying the affected customers, and fortifying the systems against the future attacks. Moreover, digital forensics can extend beyond traditional IT environments to include Internet of Things, IoT devices, used in supply chain monitoring and management. Ensuring that digital forensics capabilities cover these devices is essential for the comprehensive incident response strategy. Incorporating digital forensics into a company's incident response plan and conducting regular exercises to test and refine forensic procedures can significantly improve the company's ability to respond effectively to cybersecurity incidents. Federal standards for the business continuity plans are ISO 27001, NIST 800-34, and NFPA 1600. Let's look into one example each, that how these are applied. ISO 27001 is an internationally recognized standard for information security management systems, or ISMS, which can be applied to enhance the security postures of a supply and logistics company, including its contingency planning and incident response capabilities. The standard provides a systematic approach to managing sensitive company information so that it remains secure, covering people, processes, and IT systems. In the context of the supply and logistics company, applying ISO 27001 would involve several key steps. First, the company would establish an ISMS based on the requirements of the standards, which include conducting a risk assessment to identify and evaluate potential threats to information assets. This would cover both digital assets like the supply chain management system and physical assets such as warehouses and transportation infrastructure. Based on the risk assessment, the company would implement appropriate controls to mitigate identified risks. These controls could include access control, encryption, physical security measures, and incident response procedures. Additionally, ISO 27001 requires regular internal audits and management reviews to ensure the continued effectiveness and improvement of ISMS. For contingency planning and incident response, ISO 27001 provides specific guidelines in Annex A, Sections A.16, that is Information Security Incident Management, and A.17, Business Continuity Management. The company would establish procedures for incident detection, reporting, and response, as well as plans for business continuity and disaster recovery. The procedures would be integrated into the overall ISMS and tested regularly to ensure their effectiveness. For instance, the company could conduct tabletop exercises or simulations to validate its incident response plan and identify areas for improvement. Furthermore, ISO 27001 requires the company to maintain records of incidents and corrective actions taken, which can be valuable for learning and continuous improvement. By adhering to ISO 27001, the supply and logistics company can demonstrate its commitment to information security, build trust in stakeholders, and enhance its ability to manage and respond to security incidents effectively. Additionally, ISO 27001 emphasizes the importance of supply chain security, which is particularly relevant to a supply and logistics company. The standards require a company to assess and manage the risks associated with suppliers and third party services. This could involve evaluating the security practices of suppliers, establishing clear security requirements in contracts, and monitoring supplier performance to ensure ongoing compliance with security standards. By extending the ISMS to include supply chain security, and company can better protect its information assets and maintain the integrity of its operations. In summary, applying ISO 27001 to the supply and logistics company use case involves establishing an ISMS, implementing risk-based controls, and maintaining robust contingency planning and incident response capabilities. The standard provides a comprehensive framework for managing information security and can help the company enhance its resilience to cyber threats and other disruptions. Now let's look at the NIST 834 application. NIST Special Publication 800-34 provides guidelines for contingency planning, which can be applied to enhance the resilience of supply and logistics company. The publication outlines a structured approach to developing, implementing, and maintaining a contingency planning program to protect mission-critical functions and systems. By following NIST 800-34, the company can ensure a comprehensive and systematic approach to preparing for, responding to, and recovering from disruptions. Applying NIST 834 to the supply and logistics company use case that we are discussing in this lecture involves several key steps. First, the company would conduct a business impact analysis BIA to identify critical systems, processes, and dependencies, as well as the potential impact of disruptions based on the BIA. The company would develop contingency plans, including strategies for recovery, restoration, and reconstruction and reconstitution of affected systems and data. NIST 800-34 provides specific guidance on developing contingency plans for information systems, with considerations for different types of disruptions, such as natural disasters, cyber attacks, or human errors. Additionally, the publication emphasizes the enhancement and importance of testing and exercising contingency plans regularly to ensure their effectiveness and to identify areas for improvement. For supply and logistics company, this could involve conducting tabletop exercises, simulations, or even full-scale tests of recovery capabilities. whereas NFPA 1600, the standard on disaster emergency management and business continuity or continuity of operations programs, offers a broader framework for business continuity and emergency management, complementing the contingency planning guidelines of NIST 800-34. By adopting NFPA 1600, Supply and Logistics Company can ensure the holistic approach to preparedness, response, and recovery from disruptive events. The standard provides guidelines for developing a comprehensive program that addresses emergency management, business continuity, and continuity of operations. So, applying both NIST 800-34 and NFPA 1600 to the Supply and Logistics Company involves conducting a business impact analysis, developing contingency plans, and implementing a comprehensive business continuity and emergency management program. By following these standards, the company can enhance its resilience, protect critical assets, and ensure the continuity of its operations in the face of disruptions. Regular testing, training, and program maintenance are essential to ensure the effectiveness of the company's contingency planning and business continuity efforts. Hopefully, this has been helpful. So, business impact analysis, a study that identifies the effects of disaster would have on business and IT functions. Studies include interviews, surveys, meetings, and so on. Identifies the priority of different critical systems, considers maximum tolerable downtime or MTD. The MTD or maximum tolerable downtime, a measure of how long a system or systems can be down before it's impossible for the organization to recover. It also relates to mean time to repair, MTTR, and mean time to failure. It's technically MTTF. Let's look into this with one example. In the context of the supply and logistics company that we are discussing, mean time to detect, MTTD, mean time to recover, MTTR, and mean time to failure, MTTF, are valuable metrics for evaluating and enhancing the effectiveness of contingency planning, incident response, and overall system reliability. These metrics can be applied to various aspects of the company's operations to improve resilience and minimize the impact of disruptions. Mean time to detect, or MTTD, measures the average time taken to identify a problem or incident. In the supply chain and logistics company, reducing MTTD can help minimize the potential impact of disruptions. To improve MTTD, the company can implement proactive monitoring and detection systems such as intrusion detection systems, IDS, and intrusion prevention system, IPS, to identify cybersecurity threats. Real-time tracking and monitoring of shipments and vehicles to detect transportation disruptions or delay promptly. Sensors, networks, and IoT devices to monitor the condition of storage facilities and inventory, enabling early detection of issues like temperature fluctuations or equipment failure. Regularly reviewing and analyzing system logs and performance metrics to identify anomalies or trends indicative of emergency problems. By reducing MTTD, the company can accelerate its response to incidents, mitigate potential damages, and maintain the continuity of its operations. Mean time to recover, or MTTR, measures the average time taken to restore the system or process to full functionality after failure disruption. Lowering MTTR is crucial for minimizing downtime and ensuring business continuity. To improve MTTR, the company can develop and maintain effective contingency and recover plans as outlined in NIST 800-34 and NFPA 1600. Implement redundant systems, backup power supplies, and failover mechanism to enable quick recovery from disruptions. Establish relationships with backup suppliers and alternative transportation provides to ensure the rapid restoration of supply chain functions. Regularly test and update recovery procedures to ensure their effectiveness and identify areas for improvement. Train staff on incident response and recovery process to enhance their ability to react swiftly and appropriately to disruptions. By reducing MTTR, the company can minimize the duration and impact of disruptions, maintaining customer satisfaction and protecting its bottom line. Mean time to failure, or MTTF, measures the average time of a system or component operates without failing. Increasing MTTF can help and the supply and logistics company enhance the reliability and availability of its system and processes. To improve MTTF, the company can implement preventive maintenance programs for critical equipment and infrastructure, regular update and patch software systems to address vulnerabilities and maintain their stability, conduct routine inspections and assessments of facilities, vehicles, and other assets to identify the address potential issues proactively. Invest in robust and reliable equipment and technology solutions to minimize the likelihood of failures. Monitor and analyze system performance to identify trends or anomalies that may indicate impending failures. By increasing MTTF, the company can reduce the frequency of disruptions, enhance the reliability of its operations, and lower the overall costs associated without downtime and repairs. Regularly tracking and analyzing MTTD, MTTR, and MTTF metrics can provide valuable insights into the supply and logistics company's operational performance and resilience. By continuously working to improve these metrics, the company can enhance its ability to detect, respond to, and recover from disruptions, effectively ensuring the continuity of its operations and maintaining customer satisfaction. Furthermore, these metrics can help the company identify trends, prioritize investments, and make data driven decisions to strengthen its overall risk management strategy. Hopefully, this has been helpful. There is a RPO and RTO. Recovery point objective, acceptable risk of loss is RPO. RTO is recovery time objective, target time to have everything up and running. And this is also significant for you to know because this comes under the domain of business impact analysis. And let's go further. Common Vulnerability Scoring System, or CVSS, used to classify vulnerabilities. Open industry standard allows for the scoring of vulnerabilities based on severity. Three groups of metrics: base, temporal, and environmental are mainly considered for describing an incident. The temporal metric group is exploit code maturity, remediation level, report confidence. Environmental metric group, modified base metrics, confidentiality requirement, integrity requirement, availability requirement. I would suggest you to look at this more of your reading, so this will allow you to understand this in more depth. The temporal metric group refers to a set of metrics used to quantify the time related aspects of system reliability, maintenance, and incident management. This group includes several key metrics that help organizations understand and optimize the time intervals between failures and duration of downtime and the speed of recovery. The most common metrics in this group are mean time to failure, or MTTF, as we discussed earlier, which measures the average time a system operates without failing. Mean time to repair, or MTTR, which quantifies the average time taken to restore a system after its failure. And mean time between failures, or MTBF, which measures the average time between consecutive failures of a system. Additionally, the temporal metric group by include time means to detect, MTTD, which assesses the average time taken to identify the problem or incident, and mean time to recover, or MTTREC, which focuses on the average time required to fully recover and return to normal operations after an incident. These metrics are invaluable in evaluating the performance and reliability of systems, identifying areas for improvement, and making data driven decisions to enhance operational resilience and efficiency. The environment metric group encompasses a set of metrics used to evaluate the environmental conditions and impacts associated with an organizational operations, facilities, and supply chain. These metrics help assess the organization's environmental performance, sustainability, and compliance with relevant regulations. Key metrics in this group include energy consumption, which measures the amount of energy used by facilitating an operations; greenhouse gas emissions, which quantify the volume of emission produced directly or indirectly by the organization; water consumption, which tracks the amount of water used in the operations; waste generation, which measures the volume of waste produced and its disposable methods; and resource efficiency, which evaluates the effective use of materials and resources. Additionally, this metric group may include biodiversity impact, which assesses the organization's effect on local ecosystems; and regulatory compliance, which tracks adherence to environmental laws and standards. By monitoring and analyzing these metrics, organizations can identify opportunities for improvement, implement sustainable practices, reduce environmental footprints, and enhance their overall environmental stewardship. Remote network monitoring, developed by the Internet Engineering Task Force, or IETF, to support network monitoring and protocol analysis, provides a standardized methods of classifying network traffic. Standard monitoring specification that allows various network monitors to exchange network monitoring data. Mean percentage error. Let's look into this with an example. The mean percentage error, also known as MPE, can be applied in the supply and logistics company use case to assess the accuracy of the forecasts for estimates related to various aspects of operations, such as demand forecasting, inventory management, or route planning. MPE measures the average percentage difference between actual and forecasted values, providing insights into the precision and reliability of the company's predictive models. For instance, MPE can be used to evaluate the accuracy of demand forecasts by calculating the average percentage between actual sales and forecasted sales. A company can quantify the accuracy of its demand forecasting. A lower MPE indicates more accurate forecasts, while the higher MPE suggests greater discrepancies between predicted and actual values. Regularly tracking and analyzing the MPE can help supply and logistics company identify trends, pinpoint areas where forecasting accuracy can be improved, and refine its predictive models by enhancing the accuracy of demand forecasts. And company can optimize inventory levels, reduce stockouts or excess inventory, and improve overall supply chain effectively. The efficiency in reality. Moreover, MPE can be applied to other areas such as evaluating the accuracy of estimated delivery times, assessing the precision of cost estimates for logistics services, or analyzing the reliability of equipment maintenance schedules. In each case, MPE provides valuable insights into the performance of the company's predictive processes, enabling data driven decisions to enhance operational efficiency and effectiveness. Hopefully, this example had been helpful for you. The Ishikawa diagram: machine, method, material, problem, failures, man, mind, power, measurement. This is pretty much like a fish diagram that we have looked into our software engineering arena. The recovery plan is technically the business continuity plan, disaster recovery planning, and the business incident actual finding. So, what we do, that is a combination that brings us a recovery plan into effective utilization. Types of backups for all changes: differential, full is all changes; differential, all changes since the last full backup; incremental is all changes since the last backup of any type; hierarchical storage management is a continuous backup that comes handy. Incident response: detection, containment, eradication, recovery, and follow up, that we have just discussed in quite detail in this lecture already. Detection is detect there is an incident, identify its basic nature, identify what systems are effective, and go to containment. Containment is limit the incident, prevent it from affecting more systems, must occur before any other phase. Eradication: fix vulnerabilities. Example: remove the malware, perform comprehensive examination of what occurred and how far it reached, ensure that the issue was completely addressed. Forensics begin at this stage. Follow up. The forensics play a critical role. IT team must determine how incident occurred, what steps can be taken to prevent incident from occurring again. Preserving evidence. We have discussed this in quite detail. An event is any observable occurrence within the system or network, includes network activity such as when a user accesses files on a server or when a firewall blocks the network traffic. Adverse events have negative results or negative consequences. Example are attack on a system, dynamic denial of service or DDoS or DOS, malicious code, unauthorized access, inappropriate usage. It needs to be preserved for future R&D purposes. Preserving evidence. Recovery often performed at the expense of preserving forensic evidence. Failure to preserve forensic information prevents IT team for effectively evaluating cause incident, makes it difficult to modify company policies and procedures to reduce risk. Forensics data is key to preventing future incidents. Adding forensics to incident response. Identify forensics resources, and the organization can use the case in case of an incident. Identify an outside party that can respond to incidents with forensically trained personnel. Weave forensic methodology into organization incident response policy. Provide appropriate training to staff and preserving the incidents. We have discussed disaster recovery, evidence preservation, and adding forensics to incident response in this lecture. Let's take one more look at this with a very small use case, and then we'll end the lecture. Disaster recovery is a critical component of business continuity planning focused on restoring vital support systems and data after a disruption or disaster. In the context of a supply chain and logistics company, an effective DR strategy ensures that essential operations such as order processing, inventory management, and transportation coordination can be resumed quickly after an incident. This involves implementing redundant systems, maintaining up-to-date backups, and establishing alternative processing sites. Regularly testing and updating the DR plan are essential to address evolving threats and changes in the business environment. By prioritizing disaster recovery, the company can minimize downtime, reduce the impact of disruptions, and maintain customer trust and satisfaction. Evidence preservation. In the event of security incident or digital crime, evidence preservation is paramount for conducting a thorough investigation and supporting potential legal actions. The supply and logistics company should have established protocols for preserving digital evidence, including system logs, network traffic, and affected data. This involves isolating compromised systems to prevent data contamination, creating forensics images of effective storage media, and maintaining a clear chain of custody to ensure the integrity and admissibility of evidence. Training staff on evidence preservation procedures and collaborating with legal and forensic experts can enhance the company's ability to manage incident effectively and meet regulatory requirements. Adding forensics to incident response. Integrating digital forensics into the incident response process enables the supply and logistics company to gain a deeper understanding of security incidents, identify perpetrators, and gather evidence for legal proceedings. When an incident occurs, forensic specialists can help reconstruct the events leading up to the breach, determine the methods used by attackers, and assesses the extent of the compromise. This information is crucial for containing the incident, remediating vulnerabilities, and preventing similar events in the future. By incorporating forensics into incident response, the company can enhance its investigative capabilities, strengthen its security posture, and demonstrate a proactive approach to managing cyber threats. Regular training, Collaboration with law enforcement and staying updated with the latest forensic techniques are essential for maintaining an effective incident response strategy that includes digital forensics. We'll see you in the next lecture. Happy learning.